Hello PU2 champions, welcome to day 1 of 21 days challenge to score 95% in second PUC. As part of today's challenge, I have given you 2 chapters for revision. The number 1 chapter was electric charges and fields from physics and the second chapter was solution from chemistry. So you need to revise these 2 chapters, understand its concept and practice the important questions from the PDF I have provided. I hope you have downloaded it. If not, the link is there in the description section. Please go there and click on the link and download the PDF right now. The PDF of most important questions should be there with you before starting the challenge. Okay. So in this video, I will be discussing the most important questions from the physics chapter, electric charges and fields. These questions are very important as they have been repeatedly asked in your previous year, in model question papers, in the pre-boards and different other exams. Okay. So let's understand the blueprint of this chapter before getting the most important questions. So first of all, you can see this chapter is a high weightage chapter as it can give you 11 marks in your board exam. Now, how is this 11 marks distributed? So 1 marker question, there will be 1 question. In 2 marker section, 1 question. 3 marker section, 1 question. And there will be 1 5 marker question. Now, this 5 marker can either be a derivative question or a numerical question. Okay, so if derivative is asked, then the numerical will be from electrostatic potential and capacitance. If the numerical is asked, then the derivative will be from electrostatic potential and capacitance. Okay, so I hope you know this relation between these 2 chapters, right? So first of all, we will start with 5 marker, then 3 marker and then 2 marker. Okay, so let's start and discuss the 5 marker theory questions. Theory questions are those means that is your derivation questions. Now see, derivations are some of those questions which are very predictable and you should be writing it thoroughly. Okay, so here I'll be talking about the first question, that is here is state Gauss law and derive the expression for the electric field due to an infinitely long charged straight conductor using the Gauss law. Okay, so you have to first write the statement for Gauss law and then you have to derive this for the infinitely long charged straight conductor using Gauss law. Okay, so second question is also like that, state Gauss law. So you can see this Gauss law is so important. It is mixed with some derivations and it is asked again and again. Use the law to derive an expression for the electric field due to a uniformly charged thin spherical shape at a point outside the shell. Okay, so if there is a shell, outside the shell you have to calculate the electric field. For that you have to prepare the derivation, and remember, derivation should be done very neatly. You should practice it again and again. So first what you can do is to just see and write down, understand the steps, then write down once and then check it with the correct answer and note down all your mistakes and then write down 2 to 3 times without seeing. Then only you can remember the derivations. The third important derivation, here actually 2 derivations are included. I have written it in 1 question. Derive an expression for the electric field due to an electric dipole. Okay, you have a dipole and the electric field due to that at a point on the axial line. Means suppose this is the electrical field at some point here on the axial line, that one derivation, and on the equatorial plane, means somewhere here. So for these 2 points, what will be the electrical field? This can be 2 different questions. It will be like any one of these can be asked, so you have to prepare it thoroughly. Next was obtain the expression for the torque acting on an electric field. Obtain the expression for the torque acting on an electric dipole placed in an uniform electric field. Okay, so what is the torque on the dipole when it is placed in an electric field? That derivation you need to prepare. So total there are 4 questions, but total 5 derivations are there. Any one of this can be asked, so please prepare it thoroughly. This is very important question. Now let's move to 5 marker numerical questions. So see, exact numericals may not be asked, but these type of numericals will be asked. So I'll be reading out the questions. You can prepare these questions, and if you have some similar questions also you can know, but basically focus on how the formula has to be utilized, how the answer has to be written. Okay, so for example, the first question is 3 point charges of 3 NC, minus 3 NC and plus 2 NC are placed at the corners of an equilateral triangle ABC of side 0.3 meter in air. Find the resultant force acting on the plus 2 coulomb charge. Okay, so next one is the force 4 point charges like 2 microcoulomb. So this is in the shape of a triangle. Okay, next one, 4 point charges like 2 microcoulomb, minus 5 microcoulomb, 2 microcoulomb and again minus 5 microcoulomb are placed at the corners of a square ABCD, okay, of side 10 centimeter respectively. Find the force on the 1 microcoulomb charge placed at the center of the square. Next question is like this: 2 point charges 10 microcoulomb and 20 microcoulomb are placed at the corner of the hypotenuse BC of a right angle triangle. Okay, so this is a normal triangle, this is a right angle triangle, and calculate the resultant electric field at point A. Okay, next is three charges. So you can see what type of questions are asked, which shapes are used, and similar questions you have to practice. Three charges each of 4 nanocoulomb are placed at the three corners of a square of side 2 centimeter. Find the resultant electric field at the fourth corner. So three corners are given, fourth corner is missing. So like this questions can also be asked. Next is four charges of +4, -3, +2 and +3 coulombs are placed at the corner of a square of each side 1 meter. Find the electric field at the center and also the direction. So this is little bit similar to your second question. Okay, you can practice this question also. Sixth one: 2 point charges 5 microcoulomb and -5 microcoulomb are located at A and B respectively, separated by 0.2 in vacuum. Okay, so two charges are there which is separated by vacuum. What is the electric field at the midpoint O on the lining joining two charges? Means at this point of time, this point of line, and if a negative test charge of magnitude 2 nanocoulomb is placed at the point O, what force is experienced by it? Okay, so you have to calculate, this point is your O. So if you place a 2 nanocoulomb charge on that, then what will be the force experienced by it? So these all questions can be solved from the formulas that you know from this chapter. So 2 point charges 5 nanocoulomb and 20 nanocoulomb are separated by a distance of 2 meter, right? Find a point on the line joining them where the electric field is 0. So in between this, you have to find a place where the electric field is 0. Next, a uniformly charged spherical shell of radius 10 centimeter has a surface charge density of 16 microcentimeter square. Find the electric field due to the shell at a distance of 20 centimeter from the center of the shell and 5 centimeter from the center of the cell. So you can understand here, this is the cell with a radius of 10 centimeter, right? They're asking you 20 centimeter, means outside the shell and inside the shell, what should be the electric field? And remember, this question was asked in March 2025. So if you have remembered the formula for this, you can easily put the formula and get the answer for this one. Now with this, we'll move to 3-marker question. 3-marker questions are very direct, okay, not too much twist questions, but fact-based questions are more probable here. So like state and explain the Coulomb's law and write the Coulomb's law in vector form and explain all the terms. Next, mention any 3 properties of electric charges. This is important question and has been repeated many times. Derive the expression for the torque on an electrical dipole in an electric field. Next, write any 3 properties of electric field lines. Okay, 3 properties of electric charges, and here it is 3 properties of electric field lines. Next, fifth question, define the linear charge density. Mention the expression for electric field at a point due to an infinite line of charge and explain the terms. So we have already seen its derivation. So if you have already prepared the derivation, this question you can easily solve. Next, moving to 2-marker question, state and explain Coulomb's law in electrostatics. Write the Coulomb's law in vector form and explain the terms. This is same as this question. So it can be asked in both 3-marker and 2-marker section. Mention any 3 properties of electric charges. This is also similar here, electric field line. So you can see if 2 properties are asked, then it will become in a 2-marker question. 3 properties are asked, it will be part of 3-marker question. Next, here Gauss law statement is very important. Okay, define electric flux, okay, its definition through an area element and mention its SI unit. This question is also very important. Next, what is an electric dipole? Its definition of electric dipole moment and its direction. Okay, since it is a vector quantity, its direction also you need to explain. Next, the charges are additive in nature. Explain this. Next, sketch the electric field lines due to an electric dipole, a pair of positive charges, then a positive charge, and due to one negative charge. So this is some diagram based questions for which you have to draw the diagram. Next, when does an electric field placed in a uniform electric field experience maximum and minimum torque? Okay, so you have to write down at what point it faces the maximum and minimum torque. 2-marker, you will write this one 1 mark, this one will give you 1 mark. Next, define electric field at a point. What is meant by source charge? These are certain definition terms. So for 2 markers, Coulomb's law, Gauss law, electric dipole, electric flux, electric field, these all definitions are very important. Okay, so children, these are the most important questions from this particular chapter. The very important thing is to prepare the derivations thoroughly. How to do, I have already told you. Once again, first see and practice, then check your answer, write down once without seeing, check your answer, whatever mistakes you have done, note it down, and again write 2 to 3 times. Okay, and on alternative days prepare the derivations. These are very, very important. Okay, I hope this video was helpful, and important questions I have already given. And once more time, please follow the challenge seriously, stick to it, and I can guarantee you 95% in second PUC final board exams. Okay, if you haven't downloaded the PDF of important questions, link is there in the description section. I have made a dedicated page for all of you, so please click on the link, go to the page, download it, and then practice all these important questions. Okay, so thank you so much, dear children, and all the best. Keep learning and start studying hard now.